Let's look at another example using decision zone maps. Browns Group is a renowned manufacturer of automotive batteries. Honda Generators approaches Browns with a rush order to purchase 100 units of a customized battery for their generators at $5,000 per unit. Browns has two options: produce the batteries in-house or outsource the production. Considering the in-house option, there would be an opportunity loss, because if Browns accepts this offer, they will lose $100,000 in revenue because they have to use an existing production line that is presently producing another battery. What should Browns do? Here is the Browns batteries example. Here we have the decision tree for the Browns batteries problem. The outsourcing option, we have two possibilities, a low cost and a high cost, and we have set it up at 50% probability. Additionally, the success of the molding operation has been set at 50%. And of course, what is unique about this particular model is the decision of outsource and in-house is immediately followed by another decision of buying the mold and molding in-house versus buying cases. This gives us trouble when you have two successive decision nodes. To better understand this problem, let's go ahead and plot our zone map. Here we have our molding successful and low cost, and the outsource and in-house options already set in place. Let's clear chart and plot. And here we have a demarcation line. And this zone appears to be in-house. But see what happens as I move out. From what we learned, when the diamond crosses this line, it should move to another region. But well before it reached the demarcation line, the decision changed to outsource. Watch again as it comes down. It's in-house. So the change is not taking place on the demarcation line as it should. Thus, as you can see, our demarcation line does not represent the true zones. The reason is for discontinuity introduced by this decision. So this is a bad way to design this type of problem. We will now show you how to design it properly. Here we have the same problem, but this time we have removed the decision node and replaced it with a third leg. In-house, mold cases, in-house, buy cases. Let's take a look at the zone maps. So this time you can see you have the three options: clear chart, plot. Now you can see three zones because we had three options: outsource, in-house mold, and in-house buy. This zone is mold cases. So we'll place it down here. Outsource is this zone. And this will be by cases. Let's see. As you can see, we can now traverse the distances and see that we have the correct zones assigned. Once again, we want to emphasize the zone mapping technique is very reliable. However, you must build your model correctly so that there are no discontinuities. We want to introduce another important piece of the puzzle before we leave the Browns batteries. That is the use of the calc page to calculate terminal values. When we first looked at this problem, I had already provided the terminal values, but let's now see how to use a calc page to determine these values. And here we have the model built already, but as you can see, there are no terminal values assigned to them. To do that, we need to go to this calc page and create our table. So let's start with the terminals. I have the 5 terminals, T3, T4, T5, T6, T7. And we're talking of 100 units. And we will do this table in terms of thousands of dollars. So the first thing to do is create the cost and revenue cells. Here we have description and the various cost elements. Let's take the terminals that deal with outsourcing. So there could be a low cost and a high cost. And here the purchase cost per unit is minus 2.5 and minus 2.3. It's important to use the minus signs for expenses, and plus signs for revenue. Here's the plus 5 because it's revenue. So here we have 250 and 350, and all we have to do is simply do a summation of all of these columns to obtain the total here. So now we have the terminal values for the outsourcing part for T3 and T4. This part is very easy. It's a straightforward column. But once we get to the rest, it gets a little more complicated. So let's take a look at the other 3 nodes. This is the buy mold and the molding is successful. The next one is where we buy the mold but molding fails and we have to go back and buy cases. And the T7 is actually where we decide to buy the cases instead of molding. Under all 3 scenarios here, we have to do some design modifications. So that's going to cost us $100,000. We also have to buy special cells, which has a unit cost of 0.3. And then for the 100 units, we have minus 30,000. In the case of the molding decision, we have to buy the molds and manufacture the molds if we are successful. But if we fail, we don't manufacture it. We go ahead and buy the cases. So we have the 2 cases here. And the loss of opportunity, because we could be producing batteries of another type in our factories, we have to recognize that we would lose $100,000 by doing this in-house. Now, simply doing the summation, we get the terminal values. Note, for example, if I want to look at the cost, how this came about, if I hit F2, it shows is 0.2 multiplied by 100. If I come here and I look at it, it's 0.3 times 100. So that's how the table is set up. Once we have this data, we can go ahead and insert it into our terminal nodes. So we have 250 and 150. So we'll go ahead and hit 250 and 150. So 238, 180, and 200. So as you can, again, this table is unique to this problem. You have to create your own table that is specific to your particular problem. That's it for this video.